to decorate, and that's okay. All right, so today we're going to talk about triangles again, and we're going to focus on congruency, and this is actually 4.3, and we're going to prove congruent triangles by using angle, side, angle, and angle, angle, side. And remember, these things are going to go in order. So let me, before I talk, let me draw some triangles and kind of explain what I'm referring to. Okay. So now for angle, side, angle, when it comes to congruent triangles, what we're going to be looking for is an angle and a congruent side, and then another angle. In other words, the side has to be trapped between two angles. So angle, side, angle doesn't mean that we randomly, if we got two of the three angles correct on two different triangles, then they're congruent. No. They have to be corresponding, and the side has to be trapped between the two angles. Okay? And then if I'm referring to angle, side, then it would be two angles and then the other side. Okay? So you have to kind of rotate around the triangle. And it doesn't have to be clockwise, but you kind of rotate around the triangle. We can go the other way too. But when the label of these proofs, or these congruence theorems is a better word, or postulates, you kind of have to go in order of the way that they label them, the way that they name them. Okay? And so, with that being said, are there any questions on that? And then we'll just jump right in to angle, side, angle. No? Okay. So let's focus on an angle, side, angle. So if the angle, side, angle then, let me draw some more triangles here. I'm trying to make any triangle will do. We're trying to prove congruence, but for time's sake, I'm going to actually copy, but that's okay. So again, what I'm saying is I have to have congruent angles, all right? So those are corresponding angles, they're congruent. And then I have to have a side trapped between another congruent angle. Does that make sense?
Yeah.
And so let's just label these. So I'm going to call this A, B, and C, and we will call this D, E, and F. And so the angle, side, angle theorem is if angle A is congruent to angle D, and line segment AC is congruent to line segment DF, angle C is congruent to angle F, then here's the theorem. Triangle ABC is congruent to triangle DEF. Okay? So that's the formal notation. That's the theorem. So in your homework somewhere, we're going to have to prove or show that we have two angles that are congruent, that are corresponding, and the side trapped between those corresponding congruent angles is also congruent. And if we can do that, then we can prove that the triangles are also congruent. Right? Remember, congruent means that all three sides and all three angles are the same. But because of triangles and the properties of geometry and stuff like that, this is kind of a shortcut. In other words, if from here, if I know these two angles are congruent, what does that tell me about the third angle?
It's also
congruent because they both have to add up to 180, right? Do I need to prove that? No, I guess I could, but I don't need to. And then if I use like the law of cosines or the law of sines, I could go and figure out the other sides are congruent as well because they're corresponding to the side lengths. So in this particular case, I just need two angles and the side. All right. So let's see what that looks like in practical application. All right. So I've got in your textbook for example number 1, we've got some triangles. And they kind of look like this. So I've got 1, 2, 3 triangles. And I think one of them is like flipped upside down. Actually, you know what? I should probably, let me do this first. Delete, it'll make my life a little easier. So it's actually, it looks like this. You guys got to make that noise too. Good job. All right, now let's duplicate this. What was I thinking? We wanted to clone, not duplicate, and we'll clone again. All right, so now I've got these triangles. I think one of them was like rotated upside down or something. Some craziness like this. And then, oh, they're not exactly the same, are they? Okay. This one I'm going to have to break apart because they do it a little different. Alright. Okay, so now this one is a little different. They did it like this. They said that this angle is congruent to this angle here, and we got this line. Alright, so now let's label this. So this is S, U, V, this is O, N, E, this is T, W, A. God bless you. And then they list some things. Well, what do we know? We know that the angle U is congruent to angle E, which is also congruent to angle T. Now we know this because we have one arc here, one arc here, and one arc here. And that means that all 3 triangles have those corresponding angles are congruent. Okay? Does that make sense? Yes.
Is the last one drawn right? Because
that's how it's drawn, and we're gonna and you're very smart to pick up on the fact that that last one doesn't seem right. That's good. That's good. Intuitively, we should pick up on that last one is not quite right, and that's what we're going to show. Because basically, what they want to know is are these triangles are congruent? That's the question that the textbook is going to ask us eventually. Are these triangles congruent? Yeah, so it looks like there's 2 triangles that are congruent and maybe one isn't, right? But we got to prove it. We got to show it. We got to go through the steps. You guys are smart. You already figured out which one it is, right? But let's go through the steps and make sure. All right, so what else do we know? Well, we also know that angle V is congruent to what?
Angle O.
Angle O, all right, and what else?
W.
And angle W. And since we're listing congruencies, what else do we know? UV is congruent to what?
OE. Line segment OE.
Line segment OE, and congruent to what?
Line segment WA.
Line segment WA. All right, so now to prove using ASA, all right, to prove ASA, I'm going to do this informally because the textbook, it does like a paragraph proof, but it's not really a proof. But I want to do it informally to make sure you guys wrap your minds around it. We have to have an angle, and then a side, and then an angle. So here, I have an angle. Here, I have an angle. Here, I have an angle. Now, trap between the other congruent angle. In other words, let's look at this other congruent angle. I have another congruent angle. I have another congruent angle. So I have this angle, and I have this angle. Notice that the side is trapped between the 2 congruent angles. So I go, all right, this triangle has it. This triangle has it. This triangle has it. Uh-oh.
Nope.
That side length is not trapped between the congruent angles. Sorry, this one's off the list. So the only ones that I can prove that are, now they may be congruent. They may not be. I can't prove it using angle side angle theorem. They may very well be congruent, I just can't prove it. So what I would say is, since angle U is congruent to angle E and angle and angle V is congruent to angle O, right? Is that right so far?
Yes.
And then I might even word it like this: line segment UV is congruent to EO, then triangle, why is that so messy down there? Then triangle SUV is congruent to triangle NEO. Yeah, NEO. Does that make sense? Now you could write a sentence. If you read in your textbook, it writes a little sentence that basically says that the line segment UV contains U and V, and the line segment OE contains E and O. Now the reason this doesn't work, this triangle doesn't work because we don't know anything about A. In other words, when I look at my angles, my congruent angles, there's no mention of A. We don't have a congruency of A. And so I know that WA is congruent to the other line segments, right? But I don't have A listed in the congruent angles. And you have to have that. Does that make sense? Okay, let's move on to example number 2.